So, yeah, this session is about machine learning for IoT data. So, I have chosen three examples also that I would like to discuss. Previously, I just gave an introduction. Of course, there were many crucial points that I discussed regarding doing machine learning the right way. Uh, because after all, we have to work with data and we have to understand the nature of data, and we have to understand that if we have good model but bad data, the results are going to be bad. So we have to take care of that. Those aspects I discussed. Then regarding different machine learning algorithms, also I gave examples and spoke that how they perform, uh, how there are sometimes some like common mistakes that are committed. Like for supervised example, I was telling that supervised learning example, I was telling that if we are doing say, supervised learning using neural networks as an example, and if you are not doing retraining, cross validation, and just reporting our performance accuracies, so basically that is not correct. So there is always a scope if we have like multiple machine learning models performing quite similarly. There is always a scope of improvement of our overall machine like learning endeavor, and it is always good, to like choose a machine learning model for machine learning tasks after valid performance evaluation. So that I emphasized a lot, because we see these days many machine learning related works. Personally, I was reviewing some papers where I saw, but then those things were lacking. So we just run once or twice some plug and play option we choose. There are many online tools available based on that, and we get results in some time span. So that is not going to help. So yeah, and other fundamental aspects were also discussed regarding when to use ML, when not, and then uh, we in this presentation will continue with some more things. So I'm sharing the screen. And so machine learning on IoT data. So this is a modern scenario for data from IoT. We see that there is lot of data available, as we were hearing that we have big data. There is lot of data available because of huge advancement in IoT related technologies, and like there are so many devices communicating data, and in clouds, in data centers, we have huge collection of data, and the data storage cost has also reduced a lot. So we understand that the size of data is going to increase only, and if we can do good machine learning, then we can benefit out of that. We can convert data into information. Then we have so many devices, and these days most of the devices with some computing power, say for example our smartphones, they come with sensors, accelerometer and things like that. So they also come with GPS capacity, and Wi-Fi connectivity, and Bluetooth connectivity and things like that. Sometimes NFC function is also available. So the computing power also of many of these handheld gadgets and other embedded systems, as well as other computing systems, is quite high these days. So we have data, we have devices, and services are also good. So we have very good computing services in the form of cloud, in the form of infrastructure as a service. So we find uh, different organizations like sharing with the payment or no payment basis computing support with the people of the world connected to them via internet. And we have powerful software applications like we have our, say for example, email applications like Gmail and online spreadsheets and things like that, uh, document editing tools and online computing platforms like Jupyter. So there are many such things, and the scenario is like this, that we have a lot of raw resources available, and in such a scenario, we had to do machine learning. Uh, in a nutshell, in Internet of Things, what we find is that there is a huge network of physical objects and things connected, as I said, and they are sharing data. And some of the devices are like quite powerful, and some have quite good general computing capability, and many of them are providing hardware and software services, and that's why they are interacting, constantly interacting. And like these things are embedded with sensors, software, and technologies for the purpose of connecting and exchanging data with other devices and systems over the internet. These devices range from ordinary household objects, like even a bulb can be connected with smart sensing and actuation technologies. And suppose even a water filter also may be connected. And suppose our water monitoring system, say for tanks and things like that, can also be connected to the internet. So such is the capability now, and this is the uh, description that is the courtesy is for oracle.inc. From there I took all the image sources. Credit goes to, yeah, most of the images I have collected from Google, so credit goes to them. So what is the projected IoT growth? So with more than 7 billion connected IoT devices today, experts are expecting this number to grow to 10 billion by 2020 and 22 billion by 2025. Again, this from Oracle. They are projecting like that. And goavega.com website reports, just like we have 26 letter in our English alphabet, so there can be 26 smart objects, or even who knows, smart collections like of objects, starting with like every English alphabet letter for every human being on earth. So that is a huge thing. So this kind of IT growth is expected. So this is something which is to be understood in detail. So we talk of fog, cloud computing, and edge computing. So at the lowest level, so edge computing takes its role, and there the role of sensing and connectivity is very heavy. So we see that there are different like uh, what is the setups. Like here we see companies, their manufacturing unit, production units. There are buildings, there are the towers, there are residential accommodations, and yeah, many things like that. Like these days we heard also, like in our state of Gujarat in India, like very good smart city project is ongoing, and like so many technological aspects related to sensing and connectivity have been used. There are sensors related to it's like fire sensing in the smart city, then related to vehicle navigation and parking and things like that. And like there are systems for 24-hour surveillance related to security. So in fact, many smart city projects have been declared, making those cities smarter through fencing and connectivity and data analytics. So this is at the lowest level in the setup of the physical level, there is a lot of role in sensing and connectivity, and we will need a lot of improvement in connectivity technology in future if the IoT is going to be heavily used. Current connectivity technologies are up to LTE, 5G is still experimental, and apart from that, we have these line connectivity support and other fiber optics based connectivity support available. There are a lot of sensing devices available. There are many like uh, what to say, sensors related to human bodily activity sensing, as well as for other like activities which are non-biological also. So for them also there are sensors available, and there are sensors for like pollution detection. There are sensors for this factory emission sensing, things like that. So all of them uh, like are in use throughout, okay, the different parts of the world, and from them a lot of data collection is happening. And after we do data collection, then the next very important step is the pre-processing of the data. When we talk of data processing, first of all we should take care of pre-processing. That involves curation, followed by labeling if we go for supervised machine learning, and then like actual processing after feature engineering and things like that. So the point is, okay, the data is collected, so they are to be properly routed. So there is need of addressing, there is need of quality of service. There may be, like here some research issues related to security of data and things like that also. So these are to be taken care of. Data is sent, and like data is to be sent to the receiver to which the sensor is connected. So addressing and quality of service comes into like play at the second layer of the communication stack related to IoT activities. So this MAC layer, and with respect to data flow, at this level or layer, data processing is the main activity. Then what happens is that after all these tasks related to addressing and that secure transfer and communication of data and data pre-processing and decision regarding how to process the data, the actual computation has to take place. So actual computation will usually take place for a IoT platform in some high performance, like computing cluster or high performance, computing servers available through cloud services usually. And there the actual algorithms related to the analytics of the data collected will be executed, and the results will be stored. So this is where the actual computation is happening for the all the IoT data that we are collecting at the lowest level of this communication stack. And that's why here the label for data flow is data management. So all these activities are related to the actual processing and storage, analysis of data, so data management. And after the computation happens through cloud computing services, then the outcome has to be presented in a presentable manner for user use. So that is the application layer. So data collected here is communicated in a form which the end users can understand. So it is communicated in that form and the topmost layer of this communication stack. And in the sense of data flow, whatever data raw data was collected and processed. So here the real meaning related to the data, that is the information from the data, is interpreted and presented depending on the different IoT application. Like if there's a video monitoring application, if there's a structural health monitoring application for this environmental monitoring, okay. for health monitoring and intelligent transportation. So things have to be done like that. Okay. In fact, like for you know examples like body area network and things like that. This one examples, yeah, okay, comes in our mind. So one of our colleague was telling, so like different variables he has used and done some kind of monitoring for old and invalid persons, things like that. So how is IoT working? So basically there are three things. Like if you design a smart system and it is involved there, so it is driven by a combination of sensors and actuators. Then it is affected by connectivity and the the business logic designed by the processors and the resulting processes uh, that are developed as a outcome of those you know uh, different logic related like analytical uh, process modules developed by the different persons. Like we say business logic, so it is quite a like it carries a user meaning that we all should understand. So the people of the different organization who have to actually work with data, so they have to design the logic and corresponding to the business logic for the data processing. Different processes are actually created. That is, the program implementations, and then they are to be executed. So sensors and actuators are basically hardware devices. They collect data. Their task is to correctly sense and collect data and route what they have sensed uh, correctly without manipulation to their destinations and connectivity. It plays a very major role there. So there are so many different sensors. Like we see here, there is humidity sensor, flex sensor, touch sensor, solar cell light sensor. So then metal detector, very heavily used in security checks. Then real-time clock sensor, vibration sensor, thermistor, infrared sensor, transmitter, IR sensor, ultrasonic sensor, gyroscope sensor, accelerometer sensor, color sensor, PIR sensor, gas sensor, smoke sensor, temperature sensor, IR receiver, infrared receiver, LDR light sensor, rain sensor, soil moisture sensor. Like one of my colleagues was guiding a project, tech project where soil moisture quality detection and prediction related to the outcome of potato growth, depending on the soil moisture, okay, soil quality and moisture content retention, moisture retention in the by the soil here for Shillong. Then photo transistor, water flow sensor. This can be used for like water tanks and for pipes also. Like one of our colleagues is working on water leakage sensing. So for IoT setup in the like municipal pipeline water supply connections. So practically these things are used. Heartbeat sensor. So I personally worked on some like heartbeat data for arrhythmia analysis and prediction. Arrhythmia is basically a, like umbrella term to mean like abnormal heart activity. So usually our heartbeats follow a PQRS, like pattern of signal. So the QRS signals are like following the usual trend, vibrational trend. So then the heart is normal. Otherwise, there are different types of arrhythmic heart conditions. So heartbeats heartbeat rates can be sensed through that, and based on that we can collect data and do analysis and predict. So there are some like standard benchmark data set available. Based on that, we can do some amount of supervised learning, and then based on the sense data we can like predict. Of course, with good accuracy we have to do that, that whether the person which is wearing the heartbeat sensor is in abnormal heart condition. Because of that there may be some fall or nausea, or chances of premature stage of heart attack or something like that, or actual heart attack, things like that. So over a say body area network, persons can be monitored. So this is just one medical sensor I'm talking about. Then yeah, alcohol sensor is also there. It is also used. So somebody is consuming alcohol or not, and we want to sense that, avoid that in some places where we need to. So there are different kinds of sensors. So here we see mostly pin-based sensors, but there may be like other, like microform sensors that may come in the form of wearables, and then like many of these sensors maybe like even smaller in size, and that can be, as I said earlier, for bulbs. So for bulbs, like there are, like I was just seeing small sensors available, so we can connect with bulb, and then we can sense the condition of the bulb, that whether the bulb is turned on and off. So where we can then use that. Okay, so we can use that for say smart monitoring of the bulb lighting. Mm. So if we come up with a smart home setup and things like that. So there are a lot of applications. So first of all, we have to understand that if you have to do something on IoT data, so we have to become acquainted with use of sensors, to choose the right type of sensors, collect data properly. So in fact, I have some like sample data collected, very recently collected data, so that I can show later. So like that, and like the second aspect is of connectivity. So we have to take care of the proper connectivity if you are doing any IoT based project. So then yeah, we have this kind of embedded devices like Arduino, Raspberry Pi, or Node MCU. So yeah, Node MCU and like Arduino, they have like similar capabilities. So with the help of Arduino IDE, we can do like programming. But Node MCU is more suitable for IoT-based projects, and this system has good, better computing power compared to Arduino, and there is Wi-Fi connectivity also. Voltage level difference is there. It's 3.3 volt based. Okay, it is a 3.3 volt like analog voltage input based device, whereas Arduino can take 5 volts like that. So these kind of minor differences are there, but that we can like manage. Okay, and then this other options are like Raspberry Pi. So for IoT based projects, still I would suggest to use Node MCU, and these are very cheap sensors. I think practically the cost of Node MCU will be around 700 to 800 rupees only in Indian currency. So like if you have to do good IoT project, so the suggestion is that we use 3G connectivity and above, and otherwise Wi-Fi connectivity. Yes, we can sometimes for like hard sensing related projects can go for 2G connectivity. Also there are like GSM modules still available that we can integrate with these new devices like Node MCU or Raspberry Pi and things like that. And yeah, Node is Arduino also, but for Arduino, yeah, all things that we have to work with for a project have to be nearby, have to be connected. Wi-Fi connectivity is still not there. So then, if we need some like internet connectivity for like this kind of embedded devices, okay, like not so high speed connectivity, we can go for 2G that I was saying, and where they can be used like for okay, like sensing in hostile areas. Okay, So there we can deploy some kind of sensors, and like once they are gone out, okay, they're like somehow lost, or okay, some animal, okay, say suppose breaks the device or battery power goes out, so they may be discarded. So in that case, okay, like we can compromise with connectivity. Main point is that what I want to say. What I mean is that, but the thing is that we choose the right sensors, and otherwise right embedded systems along with combination of sensors, whatever things we want to sense. Okay, because um, along with sensing, like if you take example of any variable, so there will be sensors and there will be some like processing capability in that variable, like sensor based device, by which the data that is sensed by the actual sensing component of that variable, okay, the data will be collected and then it will be dispatched to the destination. So so there we have to do that combination of choice of sensor, and like the relevant device like node MCU versus Arduino versus Raspberry Pi, and then the connectivity. So we can go for Bluetooth connectivity also. So that comes with the cost of like battery power only, and NFC functionality is also there. And for many of these like connectivity technologies, we can purchase like like add-in devices and connect to our you know in the development you know, the like system, because basically for this kind of project, what we'll do is that we'll bring in a node MCU or Arduino device, okay, say node MCU device, and we get a Wi-Fi there. Hmm. Suppose for Arduino we don't get GSM connectivity, so we'll put a add-in GSM connectivity support, say Bluetooth. For Bluetooth dongle, if there is a USB port, so we can get a Bluetooth dongle and then we get hold of Bluetooth connectivity. Then we can collect. We can do simple for this Node MCU Lua based programming. There is some programming language support. There sometimes there is Python support. Then yeah, based on that, some programming you have to do. So based on that, we get different kind of connectivities, and then we can have multiple devices connected, sharing of data. So we can start like this, and in real life, what happens is that when these kind of projects are emulated, then these are like then given a fabricated shape, and ultimately we get a wearable device or a device that can be attached with a device which is to be sensed, like for a bulb I said, a small device. So basically that before making the device, some experimentation, as I was like speaking little illustratively, that way was done, and then finally that outcome came. So then these way so many variables have come up, and they are transmitting data using different connectivity supports that they have been equipped with. So here, and we know many of the names of these different connectivity technologies. So yeah, we can start from simple IPv4, IPv6 based connectivity, so LAN cables. Then we have this power line, Internet, Ethernet, this RFID, okay, ANT, NFC, Zigbee. These things have come. Okay, supports for many of these older technologies may not be available for newer wearable and newer like embedded systems that are being introduced for IoT-based project development. So these things we have to check out if you want to really develop a IoT-based project, do some research, collect some data, publish some results like that. So yeah, then there are so many other connectivity technologies as we see here. So dash 7, then license fee spectrum WiMAX, weightless 2G, GSM, Edge, CDMA, FDO, 3G, GPS, GPRS, for cellular 4G, LTE, LTE Advanced, 5G also is being used in some countries these days on experimental basis. And along with many of these connectivity technologies, we have some protocols. So as Dr. Soman has earlier talking, so we should have to collect some knowledge about, gain some knowledge about these protocols, because that will be required for, like doing some programming sometime. And like as we see here also a diagram. So based on that, many like things are connected, houses, vehicles, buildings, even plants also, like smart agriculture, uh, you know, like based systems, smart agriculture system based on IoT. So, like uses, okay, like the sensing from the, like plants also and trees also, like that. Then the third component that drives smart systems and IoT is people and processes. So what we see here is that for people, uh, like there are aspects like customer relationship and support, then analytics and cloud, along with the associated API. APIs to be very good, nicely developed. There should be good support, documentation, and a lot of examples to start with. Then location and tracking, and some financial data input, remote monitoring and maintenance, like that. Then for processes, mainly mobile devices and apps, okay, security, energy, supply chain management, control automation. So along with all these activities, what we see is that, like people associated more with customer relationship and support. Okay, both have the process aspect and people aspect. Okay, the customer relationship and support will have less process aspect and more people aspect. But like for analytics and cloud and API, the process aspect is more. People are involved there, okay, definitely. And similarly, for other things like location and tracking, financial again, yes, people will frame the rules, and accordingly, the relevant processes will be developed. Okay, from the implementation point of view, remote monitoring and maintenance. Okay, so people are there, so they frame rule like how this monitoring logic should be, and then like appropriate computational processes developed based on the algorithms designed by the people and things like that. Similarly, for so many other activities. So for all these activities, there is a people aspect, there is a process aspect. So there has been like a very fast evolution of technology in the past few decades, 6, 7 decades. There have been so many generations of computers from first generation to second generation, third, fourth, fifth, sixth. I don't know whether that kind of differentiation has come or not yet. And similarly, the uh, you know, software side also has seen so many generations of development. And in the present era or age, like we are at a stage where we see that we have terribly big amount of data. And why that is happening, the reason is also mentioned there, because when we are talking of data processing in the IoT session, this discussion, like this idea comes immediately in mind. So if you talk of numbers, so easily, numbers take 5 KB per record, text 500 KB per record, images 1000 KB or 1 MB per picture, say typical image resolution. If we consider audio, say 5 MB per song. Video, so say here it is, yeah, 5 GB per movie. High resolution can go up to say 50 GB per object and things like that. So we are living in an age where that we are working like heavily with all kinds of this kind of data. In the earlier ages, people were not doing much computation on video and audio of big sizes or images of very high resolution. But nowadays, we have such storage capacity, and we have such computing platform, and we are dealing with such kind of data, and we are going to deal with such kind of data, and even in large in the upcoming years. And after doing that only, we are going to achieve some results in connection to our IoT related tasks, okay, and data processing related tasks in connection to IoT. Then technology with respect to better hardware, okay, like that is a typical discussion. We know that moves law and things like the transistors have doubled in the microchip, and in fact, because of that, even people are talking quantum computing these days, okay, as a assistive computing technologies to current like computing like systems, and computation speed has significantly increased. The cost per gigabyte has reduced drastically, as we see. As on 2015, the cost per gigabyte is just $0.03. So we have improved a lot in terms of hardware performance. We have improved a lot in terms of smarter algorithms. So there have been a lot of computational, theoretical, and practical advances in training a multi-layer feed for neural networks. So yeah, why if we think like about machine learning, why we usually think of using these neural networks? Because this AI technique has given the best of the results in the past decade. In fact, the core idea of deep learning has revolutionized the AI industry. So way back in 2006, like the inception of the foundational concepts of deep learning were laid out, and then Lee Kuhn and Hinton and other researchers, so they have eventually come up successfully with this idea, and now these things have been put into use, and we have seen like magical change, in fact, in machine learning based data processing, and uh, for certain tasks, performance at par with human level performance and things like that. So a lot of theoretical advances have taken place, and we have got many smarter machine learning algorithms these days. And because of the advancement in the hardware, and for many like problems, we have now huge amount of data available. So we have been able to like actually realize these smart algorithms that needed training, like which were earlier like mostly studied theoretically because of lack of processing power for process huge amount of data for training and learning. So that has become possible now. So I guess we now hear a lot about this image net being used, and there is another concept in machine learning called use of transfer learning. So like it was not so much imaginable to process, I think, 22,000 categories of images that are there in ImageNet, uh, to actually come up with a very good training outcome that can be preserved. So that could not have been possible, but with the introduction of GPU technology, thanks to the GPU technology. So we wonderfully gained performance in like doing in achieving parallel processing, and as a result of that, actually a lot of data processing could take place in connection to uh, like training of supervised machine learning models. So the theory about which was already introduced to the world, but they could not be realized, they could not be actually seen to be put into work because of these limitations. But with the like introduction of these theoretical like concepts, due to advancement in theoretical like computer science research, so it was then eventually found out that parallel processing could be easily done through the use of GPU, and because of increase in computing processing power, as well as the high availability. So it has become very much possible now, and now we can say, like use a saved training. That is what is the core idea of transfer learning. So we can use a saved training, already saved training, and apply it uh, and like similar like problem uh, for similar this data domain, and can get the result from the machine learning model. So, new mathematical techniques for optimization over non-convex curves led to better learning algorithms. Like many times we see that we need nonlinear boundaries for classification, as well as so for like this some optimization techniques also we need, the like like good techniques for solving, this um, like the mm, solving means what, finding the values of the parameters related to non-convex curves. So their advancement has taken place. So uh, yeah, so these things have actually helped us a lot in coming to a stage we are right now in connection to machine learning for huge amounts of data, including complex, machine learning models like the models related to uh, deep learning. And in fact, I also said like there is another complex neural network machine learning model called spiking neural networks, first neural network models. That also, some of you can, who are interested, can see and study. Okay, now what about the data? Okay, now when we are talking of working with machine learning on data, so these fundamental aspects should be taken care of. Like the gathering actually might depend on human work. So when we collect data, suppose we have gathered data through sensing. So the very next thing is that data will be just like shipped to the destination via connectivity. So the very next thing will be then how to use that data for doing some supervised learning. As I said earlier only in my previous presentation, and that is the general term that mostly we go for supervised learning, okay, for IoT data, because classification regression tasks are very popular, but it doesn't close the scope of doing unsupervised learning and clustering. If needed, we definitely can do. In that case, labeling will not be required. But if you are going to do supervised learning for the data collected from different sensing devices, then we have to do labeling. So how do we do the labeling? So for that we have to label in a foolproof manner. So there are things like kappa measure, kappa score, that takes care of the agreement of labeling for different manual laborers. If we employ human beings for doing labeling, so then that is required. Kappa score calculation and things like that, and there may be other mathematical ways. This is one of the most popular means that is employed for scenarios wherein for doing supervised learning we have to do manual labeling. So, suppose I collect the accelerometer data related to detection of human activity, for an old person, suppose over a body and network, I'm monitoring that whether the person is going to fall or not, whether the person is in upward position. So, continuous sensing of data is being done. Data is being continuously sensed, generated, and stored. Now, based on that, I have to prepare a machine learning model so that after the preparation of the model, so I can be at peace that through the model's prediction, I can get a rough idea that currently the person is in what situation, in a false situation or not. So, the next thing is that okay, I have the data, I have to do labeling. So then for labeling, I have to employ human beings. Then we have to use domain knowledge and then put levels that okay, if this is the record for the different parameters sensed by the different sensors over the body and network from the persons who are being monitored, then what should the level? So accordingly, you have to level. Then there should be level agreement calculation done, and sometimes labeling is very difficult also. So easier said than done. What I said was like for a simpler scenario, I'm like enthusiast and very interested to develop IoT based projects. So I'll just put sensors and keep some like dimensions or like features per record, and based on that I will make some assumption and label accordingly and get good results. So that is not always possible for harder problems, suppose, and especially for say mission critical problems, if and like problems involving life and death. So if for say some sensible medical data I have to like contribute in an IT project, so I cannot think as a developer that I will level. I have to take help of doctors, definitely, because they will have more domain knowledge. So they have to suggest the labels, and then the labeling has to be done. There may be some more agreement required between, say, you know, like some doctors. We may take help of multiple doctors, and then the labeling activity may be done. So they're very important activity in doing machine learning, that the labeling has to be done properly, because that very thing will decide the quality of supervised learning. So this is a very important activity, and labeling requires domain knowledge. So many times experts are you employed because they have the domain knowledge. So then sometimes what happens, I can get the data free also, sort of like machine translation. In the like branch of NLP of AI, there is a hard problem of machine translation. They say that the holy grail of AI is NLP. So, and the holy grail of NLP is for like machine translation, like that. So it's a very tough problem. So, okay, so we get translations for that, like mostly from humans, because in AI we say that there are different task domains. So there is mundane task domains. There are like formal tasks. There is a domain of expert tasks. Mundane tasks like vision, perception, translation, vision, these are the easiest tasks for human beings. Whereas formal tasks like theorem proving, game playing, so it's like a 50-50 situation. Like it is sometimes easy for some humans and sometimes easy for machines also, like playing chess and things like that. But expert tasks like, say, manufacturing and planning, and things like that, industrial automation. So these are like expert tasks. Here parameters are fewer, and these kind of tasks are easy for computers and harder for human beings. But machine translation is a easy task for human beings. So like lot of like translations for a particular record can be like available from the humans. Okay, so and in that case we understand that the translation given by like the humans, okay, are more correct. And here we don't need much of domain knowledge, right? So if I have take care of, like I was like, in fact I'm working with an MTech student regarding translation of regarding translation of user commands given in like local languages to English, for home automation. Okay. So there, if somebody is writing, suppose "Balbwa jalai de," so it's in, I think Bhojpuri. So I'm not a Bhojpuri expert. So then, this is not a difficult sentence to translate. So here we do not need too much domain knowledge, and here, like the translation that humans may give, any local Bhojpuri speaker can say that it's about light the bulb, who also knows English. So we get a sort of like correctly labeled data, like for freely. That's what. So next thing about data is, or doing good, for achieving good machine learning outcome is more the better. So there are certain machine learning algorithms or models that need a large amount of data to be practically useful. Example, neural networks. So they need several retrainings for proper well performance validation, and like different choices of like training records each time. Good amount of data is needed for training neural networks. So for this, the saying goes is, the more the data, the better. And the next thing about data for doing good machine learning is, the quantity and quality of data dictate the model accuracy. So we have to take care of the quality also, like as I said. So assuming all the first 3 points were uh, related to correct data, is the data we are working on is correct. Okay, so that's what. So then whatever machine translation we get will also be correct, like whatever labeling is happening, that also will be correct. But the quality of data, so you know one thing we should understand is that we can not just apply like machine learning on any kind of data that we get and we'll get some outcome. It's not possible. And especially when we are using physical devices like sensors, so they always have their own limitations. So despite best of the like implementation of best of the algorithms for cyclic redundancy check and transmission error checking and correction and avoidance, there may be problems, there may be security breaches and all those things. So when we are talking of IoT projects, so these aspects will be taken care of because this will affect the quality of data apart from many other factors. So starting from that level, we have to start thinking when we have to come up with a successful IoT based like machine learning project. So IT data has to be like good in quality. So, because when we are talking of just like a event example, if you're talking of distributed system and say a centralized system with respect to say DBMSS. So in the distributed database management system, we cannot take care of the consistency of data like very rigidly. There may be chances of inconsistency, and the remedial measures have to be taken to keep the entire distributed database in a consistent state, okay, through several phases of committing, okay. And that is not the case when we are suppose working with a DBMS hosted on a single machine. So similarly, when we are talking of a project involving different devices connected remotely, so the quality of data will be affected by those additional like factors also. Apart from like manual tempering that can happen anywhere. So the incorrectness introduced due to technical aberrations, okay, can affect the quality of data. Security issues may affect the quality of data, and like that. So then when we collect data, then we also need to do data pre-processing. So there may be some questions, okay, raised, because uh, there may be missing values, because as I said, we have to do leveling and things like that. So that comes after we can do correct pre-processing. So these questions have to be raised. So we, okay, uh, sometimes get records like one example comes in our mind. Once I was saying that in hospital, what happens is that there are nurses, and other health workers. So because of like huge workload due to practical pressures, so they sometimes keep records or make record entry of several patients towards the end of a day at a time, right? If they have to like keep records of several factors related to a patient's health record, and they are supposed to like enter the health record after every patient's like treatment or diagnosis, or like every after meeting with every patient, okay, with the doctor. But sometimes that is not practically possible. There may be like like so much influx of patients, that sometimes they are overworked and they may do at the end of the day. So there may be mistakes, there may be missing values. And then suppose if everything is correct, so it's not that every record will follow the same trend and pattern. So there may be outliers. So uh, like there may be for text data, as I said earlier, that for text data we have to give some proper representation. So there are different techniques like using the vector space model representation, or using some word amendment technique based on n-grams or based on character n-grams and things like that. So whether the encoding of the text, okay, happens nicely or not, so it's for one kind of data. So this okay aspect has to be taken care of during the pre-processing stage before doing ML on the data. Then wrongly labeled examples. Okay, so as I said earlier in the previous slide, so if we get data, okay, which is we do not like have the problem of missing values, let's say. Okay, outlier is there, no problem. So we get raw data but there are no missing values, then we can think of labeling. But if the labeling is not properly done, like if there is no validation, okay, of the labels given by different human labelers, and if sometimes we don't take help of the experts, domain experts, for the data uh, related to the domain of the particular expert, so the labels may be wrong. Then there may be such kind of data collection occurring wherein we say that there will be unbalanced number of records for the different classes within the data. So we say that that in such a case, we are working with unbalanced data set wherein samples for some classes will be too many, and the number of samples for some other class may be too less. So in that case, for the class that has less samples, we have to take special oversampling methods and similar other techniques. So all these are like important steps of pre-processing. Pre-processing is not just sometimes they think about removing error or mistakes. Okay, because there is just one point here that I mentioned, like missing values, and for that we can use average method and things like that. There are ways. Hmm. And if there are like syntactical like mistakes, okay, like in the input level only, they definitely there to be corrected, okay. But then apart from that, these are also falling in pre-processing. Like how do we encode? Like we get raw text. Suppose we get social media input text, or we, as I said earlier, for that one example, that we get like transliterated natural language text for user commands for like smart home devices. So I make a repository. So the input is not wrong. Input is not wrong, and there is like no missing record. But then if encoding is not done properly, so preprocessing has to be done. Similarly, if the labeling is not properly done, there is problem. Similarly, if we have like unbalanced classes in the data, so first of all that has to be taken care of, then the labeling may be done. So these are very important points which should be very properly done, because just the application of a good ML model doesn't give us result. The background work that we do, followed by proper application of ML model, will give us the desirable results. Then need to fix or remove data for achieving good training, okay, and good like what to say, supervised learning for a supervised classifier. We may need to fix or remove data, especially like out of the trend data. Sometimes we do that. So some fixing may need to be done, because like uh, if we have like too much variation in the data, then we know like correlation between the records of same class can be nicely obtained mathematically, because neural networks are known as universal function approximator. But if they're like there is too much of like heterogeneity in the training data, then they may not perform well. Similarly, there are other supervised classifiers, okay, so they also okay should be like having uh, like input for training where there is not much of heterogeneity. So sometimes removal of some records from the data needs to be done. So that also falls under data preprocessing. Then we need to do feature engineering. So how we can define a feature? A feature is an individual measurable property of a phenomenon being observed. So any phenomenon may be seen from different aspects. So for if for some of the aspects of a phenomenon, if we assign some value, okay, that is what we are making that aspect as measurable. So that becomes a feature. So usually a feature represents for an input a dimension. So the word input, pattern, observation, these are synonymously used in the discussion of machine learning. And feature, dimension, attribute, these are synonymous. They represent one aspect of a pattern, one feature, or one dimension. of a pattern, input pattern. So our inputs are represented by a set of features. So every input is encoded, okay, to a set of features. So suppose if you have to classify spam email, huge amount of data we are gathering. Okay, suppose we make a customized IT solution, okay, and we develop a app based on that. So wherein the employee of the organization, okay, are using that app, and somebody trespasses starts sending like irrelevant messages. So they are called spam. Spam means irrelevant messages. So then, okay, to classify these irrelevant messages that are like affecting the performance of the app, we have to suppose do classification. So we have to find out. And these days there is a lot of use of creative spellings, abbreviations, short form, like we use GTG for got to go, GR8 for great, and things like that. So like here one example is shown changed. Number of words have been changed. So these are not to be found in any machine readable dictionary also, MRD. So change. So for looks somewhat similar to capital A, and even sometimes small a also, and E, capital E. So three. So just the reverse of capital E changed. So if these kind of things are there, okay. So this time these kind of things are possible in a email, spam email. So sometimes we get emails of other languages also, spam, and then there may be too many use of emoticons, smileys, and those kind of things. So these kind of features have to be identified. So after we do data pre-processing, we may uh, label, or we may do feature engineering, and then get some dimensionality reduction also, and then also we may label. Both way it is possible. So that previous example was related to text data. So continuing with this discussion of feature engineering. So extract more information from existing data. Okay, that is also another nice activity. So if we can extract more information from existing data, not adding new data per se. Sometimes there's a misconception. We think that okay, we are not getting good ML performance, so increase training data, get more data, train new data. So that may be costly. New data sometimes is costly. Okay, so instead of that, what we can do is that we can extract more information from existing data. Like there is a concept of data feature in case of DBMS as we study. Like from date of birth, we can find out age. So similarly, from existing features in the data that we get in the raw data, we can interpret out new features. And from the existing data only we can get new information, and that you know raw data can be transformed based on the new features identified from the raw data only, and that kind of data can be means that transformed form of the input raw data can again be used for this training. Okay? So that is another good way. So making it more useful, existing data only, instead of trying to get new data, just plug and play more data and get performance. So that doesn't always work. Then with good features, most algorithm can learn faster. So sometimes, okay, this misconception is weird, but it is not like this. We have to try to find out good features from the data. That is always important, and that helps. So feature engineering is something that can be called as an art. It requires thought and knowledge of the data. So if we have good knowledge and understanding of the data and thoughtful about the data, so good features can be brought out. Of course, when we use deep learning, so features are learned by the deep learning model itself. But for many other types of data where we are say not using deep learning for finding features, so features have to be found out very nicely. So that is an important aspect for getting good machine learning performance on data. And like this involves two steps: variable transformation, like we can convert dates, okay, date information to say how many weekdays in the data that I have collected. Where date information is there, I may be interested to find out weekdays. Suppose I'm talking of say home, electrical consumption data. So I prepare a IT network. So I am monitoring, okay, electrical load, means electrical data for forecasting electrical load and things like that. So in that case, we see that on weekdays usage may be not that much because I'm usually out of home in the office. But on weekends, there may be okay more usage. On festival or holidays, there may be more usage. Sometimes there may be cut out, so there will be less usage. So in that case, like I am saving date-wise record, and also suppose I'm keeping meter reading. So in that case, from the data, I can find out a feature that how many weekdays are there in the data and things like that. So normalization. So it's like transforming. So as I said, in like giving the raw data only a new shape based on the features interpreted from that raw data. So giving that raw data a new shape and then using that data only instead of like adding plug and play new data too frequently. Then feature creation. For example, n-grams on text. Now text comes in raw form with these letter symbols, text symbols. They can be given a numerical representation using n-gram, character n-grams, and things like that. If word is capitalized, then we can use that information to like see that there is a possibility of name coming. Name start with a capital letter. So this is an example of text data. So the first one was the numerical data. Okay. Then machine learning algorithms learn from data to find hidden relations, to make predictions, to interact with the world. So just summarizing many things we have already discussed regarding machine learning, but still some summary points. So machine learning algorithms learn from data to find hidden relations, to make predictions, to interact with the world. So basically through those sensor devices about the IoT. So if like data is collected and some ML is executed and some interpretation, some information on the data comes out, so then that is transmitted. So it is like interacting with the world. So a machine learning algorithm is as good as its input data. Good model plus bad data is equals to bad results. So today most popular ML uh, today's it should be today's most popular ML technique, deep learning, is making significant breakthroughs in. So deep learning is today's most popular ML technique, and it is making significant breakthroughs in speech recognition, language processing, computer vision, control system, etc. So this is another important thing to note. In the current era of machine learning, deep learning is the best performer. So now some like ML and IoT based examples I want to discuss. So first example is smart homes. So like here is a schematic diagram. This from DigiHome platform source. So smart home respond to a user with a smartphone. So suppose user with smartphone enters the room, and there are like occupancy sensors. Like in the first introduction to IoT lecture, we were seeing that when persons were entering, so room occupied. If they're entering the bathroom, so like that, going out unoccupied. So there may be some sensors fitted near the entrance that will collect the data that somebody is entered or not, and then that data may be, as I said, processed, feature engineered and labeled, and then we can apply ML model, and then we can predict that whether the room is occupied by a person or not. So occupancy sensor detects his presence and notifies set-top box. So if that occupancy is connected via internet to the set-top box connected, then there the display can come occupied. So STB looks for user profile in the mobile device. Now STB is already integrated with a database, so it searches there, and then STB adjusts the temperature. Now if it is adjusted, if it is connected, okay, for temperature control and lightning level control according to the user's profile information for the user's preference, then those things also can be taken care of, and a hello message also can be shown, as we see here, hello Lucas. So it's a practical example of like doing machine learning for a IoT mini IoT setup. Okay, and yeah, like there may be what to say, like some model decay in this case that also can be improved by periodically the model designed for this entire system as I described. Okay, through retraining, that also we can do. So as we discussed earlier also, some large amount of data is required. So this is one example. So from that we get idea that how ML works and what all technologies will be required. Sensor technology like smartphone and Arduino will be involved, or like Node MCU. So communication technology can be BLE, Wi-Fi, machine learning. Several ML algorithms can be used. We can first with simpler ML algorithms, then we can try with neural networks and human-machine interface (UI) UX can be for app. We can have an Android app designed. So this is now with respect to this research paper, a mesh network for mobile devices using Bluetooth Low Energy. So this was in IEEE Census 2015. So here we see setup, IoT setup. So there are like handle be this uh, lowermost layer is the actual framework that has this Android support and Bluetooth support. So this represents the smartphone, and there is interaction with the underlying subsystem. So it is taking care of the parent, okay, and their relevant information items, and then there is one layer that application like share files or any third-party application like that. So this may be the interface. Okay, this is the interface internet. So like this we see here. So somebody saying say hola, namaste, hello, hi there. Okay, to know the status. Okay, the chat app. Okay, mesh chat app. Okay, the mesh network devices. So it is taking care of the like devices and interaction. And yeah, this is another example related to a smart pencil grip monitoring system for kids using sensors. This is something interesting. Like different children, they develop different writing habits. So in this example, we see that like this is not so correct way of handling like gripping a pencil. This is fine, of course. Both cases are considered like right-handed writing and left-handed writing. Yeah, this is best out of these three. So like what can be done is that like what they proposed is in the authors, what they proposed is like they use sensing, they connected sensing with a pen, as I said earlier. Like it is really different now. So like a pen is also getting connected via internet connectivity for IoT, uh, like based processing, okay, using some machine learning algorithm for like knowing a particular status of the pen, whether the pen is being held or gripped correctly, and who are being monitored, okay, for correct gripping of pencil, pencil, yeah, diagram, yeah, is of course here. So like that, and based on the movement and the like positioning of the pen, so prediction can be done that whether the gripping was correct or incorrect for right-handed writing, for left-handed writing. So as we see, for left-handed writing, this is good. Okay, this is best. This is good. This is not so good, like that. So uh, this is the layout that they suggested for sensing. So x-axis is considered to be perpendicular to the pencil, and y-axis, okay, is along the like uh, pencil, and z-axis is the third one, right? The 3D in the 3D space, and the accelerometer is fitted at the top of the pencil. In this for that project, they fitted the accelerometer at the top of the pencil, and then when the movement happens, then the accelerometer data is gathered, that is being transferred, that is being collected, and based on that, the ML is training itself and then predicting that whether the grip was correct or not, or incorrect, whether the movement is happening rightly. So thank you very much. These are like so many like points that I wanted to share and discuss. And three interesting examples that I selected, that also I shared. So we can have some comments, discussions now, if there are. In chat also, if required, you can ask. Thank you. Okay, okay, okay. So, yeah, sorry, I got muted. So the question is data cleansing part of pre-processing? So I want to ask that here the word cleansing is little general, English, like having general English meaning. So technically, what you are asking, if you clarify, is better. Pre-processing usually involves correcting errors in the data, input data, and things like that. So cleansing, if it means removal of certain columns or attributes, like as I said, removal of certain records can be done for improving machine learning performance, especially training performance. If presence of certain records or columns like introduce heterogeneity, okay, in the data. So in that case, if you're meaning by the word cleansing, removal of columns, say after you have already trained with data, so then that cannot be called pre-processing. If you comment back on what you exactly meant by data cleansing, then I can comment more. I think it's a question of Ganesh Rahate. Yeah. So if you revert back, then I can comment more. So I think, yeah, you asked in a general sense maybe. So yeah, we can is not a very standard techniques. There are other techniques of like combining certain features. Like a feature is represented by a column or dimension. So from the combination of features, we can come up with a new feature, and the old data representation can be improved, and that improved representation of data can be used for training again. Okay, if that is the idea, that can be done. So in that case, like it becomes a like systematic work in relation to machine learning. Abruptly deleting columns sometimes is like ignoring columns. That also is possible. Like that is like feature selection only. Instead of feature engineering, then it's like feature selection. So a input record is represented by several features. So I select a few. Earlier I was selecting 4 features to train. Now I'm selecting 3 features. So one node in the input layer will be reduced if I'm using say new network, okay, or something. That way also, it can be seen. Okay. So I hope everybody has got the online feedback link and attendance link also. And yeah, so if there are no more questions, then okay, I can end here. Thank you very much for your cooperation, patient listening. We'll meet tomorrow and see some demo hands-on related to IoT data processing using machine learning. Thank you very much.